Hello. How are you guys doing today? Good. Good. Where is everyone? The rest of the people.
That's rush.
Is there any train late or anything?
Huh?
Is there any train late or anything? Anything happening? On subway, on bus?
Accident.
Two accidents?
I got into a little accident.
Oh,
I'm okay.
why? What happened?
Accident bumped into someone.
Oh, man. Oh.
Yeah, that's like get off for 14 minutes. Not today. You know, get off at 20 years, but then it didn't work.
So did you walk from 14th Street to here?
Yeah.
Really?
Yeah.
14th to 23rd?
Yeah.
Wow, how long it took you?
How long? 10 minutes.
10 minutes
10
and you walk 10 block?
Yeah, like 10 or 5 minutes. I will do it.
Wow.
Very much.
For me, it is surprising because I never walked that far. No.
No,
I did once from City College to Lexington Avenue, 125th Street. It took me 50 minutes. 50. Because I was walking slowly. So with bus, it takes 10 to 25 minutes. And only once I wanted to try it, see by walking how long it takes. And it took me 50 minutes. Yeah. And then my feet hurt so badly.
yeah.
Mm-hmm.
Today. Well, I need things, I'm pretty sure I want things. And so I think if we did again, stress. Right. You know, a lot of people want to come here and see and visit.
True. Okay, so we are in section 12.3, I think. I forgot the section. So in our last question?
Are we doing logarithms now?
No, real life application of
Okay.
exponential. So I said there are 5 types of exponential equations, and based on each type, we take our steps differently. First step is different, the rest of the steps are same. So the first scenario was we are given the same base. If you have the same base, we can simply cancel the bases and set the powers equal to one another and solve for x algebraically. Second scenario was we have 2 different bases. However, we can convert the bigger base in terms of smaller base. So bigger base is a smaller base to some power. So first step, we rewrite the bigger base using the smaller base. And then we have the same base, we cancel them. We set each powers to equal to one another and it's solve for x. And we use the exponent rule that when you have 2 powers next to one another, we're supposed to multiply them. We never add them, we always multiply them. And then we did few examples on this. And then the next scenario was we have 2 different bases. Julia. So the third type was we have 2 different bases and we cannot convert the bigger base into smaller base. So what you do is we look for a common base that is smaller and we can rewrite both bases using that common base. For example, 8 is 2 cube and 4 is 2 square. So we rewrite them using the base 2. So when you have the same base, we cancel them. And just like the previous one, 2 powers together means multiplying. So we set the 2 powers equal to one another and algebraically solve for x. And we did few examples on this. Now comes the fourth side. We have two bases that are completely unrelated to one another, and they do not have any common base. So there is no way we can rewrite them. There is no way we can write the bigger one as a smaller one. Since we have this scenario, and also one more thing, that we have two bases, nothing else. We have both bases completely unrelated and only two bases. We have only two bases scaled. Yesterday I was teaching this class at around 10 or 11, a scam call came. Now I'm teaching the same stuff, another scam call came. Like, are they monitoring me somewhere? Whenever I teach this subject, they're calling me. Probably they want to give me some comments. Who knows?
Who knows? They want to compliment.
Exactly, or give me some suggestion to improve myself. So we have only two bases, and they're completely unrelated. So in this case, we use a new concept. It's called log. So there are two types of log. Log is a function. It's a machine. So we can insert anything in that machine, and then they do their job, and they spit out something different. So what log does is it makes numbers smaller. We give them a big number to work with. It blends the number, and it spits out small number. And we have two types of log machine. One is log, which is simple log, normal log. And we have another type of log, it's called ln. ln means it's natural log. So the log is normal log. Normal log. And log means, ln means normal, natural log. Okay? So every log has a base, invisible base. And this log doesn't have any base. It has invisible 10 base. Okay? And ln, it doesn't have 10 base. It has invisible base e. Base. So we can apply any one of these both sides of the equation. As a result, the power will come down. Log is a very jealous machine, okay? A very jealous function. It hates power. Anytime we have some type of power to work with, and if you apply the log hates power, so it brings it down as a coefficient. So log has a property, a special property. If you have log anything with power, it brings the power down, and we have times log b. So this is the property of log. If anything has a power and we apply log to that, the power comes in the front as a coefficient. So that's because of this property, we can apply log here because we want this power not on the power, but on the coefficient. Clear? So our x is on the ceiling. So we cannot touch x unless we bring it down on the floor. So the process of bringing our x down from the ceiling to the floor is the log function. So log works as a ladder, okay? So we have our x on the ceiling, we put the ladder on, and then our x comes down. That's the story. So instead of using log, I would like to use natural log. So we have 7x minus 2 is 3. I'm going to apply natural log to both sides. You may wonder why natural log? Why not log? Well, you can use log, but I want you to have the habit of using natural log. Why? Because our next type of question has base E. And for base E, you must use natural log. You cannot use the normal log. That's why I want you to use natural log for any case. So you don't get confused when to use which one. So we applied log. Log fights with the exponent. Log fights with the exponent and it brings it down on the coefficient. So we get x minus 2 ln of 7 equals ln of 3. So power is not on the power anymore. It came down and acting as a coefficient. X minus 2 is now a coefficient to ln of 7. Since our goal is to get this x alone, and between x minus 2 and ln of 7, we have an invisible multiplication. So in our next step, we want to get rid of this ln of 7. So we divide both sides by ln of 7. So they cancel out. We get x minus 2 alone, ln of 3 over ln of 7. What is our last step to get the x alone? We don't want these two, so we add the 2. That tells us our final answer is ln of 3 divided by ln of 7 plus 2. This is our answer. If this question is on non-calculator question, because in order to find how much is this, we must need a calculator. So if it's a non-calculator, we stop. But if it's in the calculator, then it cannot stop. We have to go to the calculator and find out how much is this. So depending on which type of calculator you have, you input this information differently. For my case, this calculator requires us to write the number first and then ln. So I cannot write, see you have ln here. It looks like in, but actually it's not in, it's ln. Let's see what things. So you see log here, ln, log here, and it looks like in versus small l, ln, it's natural log. So in my case, I have to insert, since we have a fraction, so I'm going to start with a big parenthesis and then 3 ln. We're dividing that by 7 ln. So that's our first portion. I'm closing my parenthesis. With that result, I'm adding 2. So that gives us 2.5645. In the final exam, the maximum they go is 1,000 place. 1,000 means 3 places after the decimal. So if you want to round 3 places after the decimal and look at our next number, which is 5, so 4 becomes 5. So answer is 2.565. 2.565. So a reminder about decimal places. After the decimal, the first one is called 10th place. The second place is called 100th place. The third one is called 1000th place. So in the final exam, they will ask you round to the 10th place, or round to the 100th place, or round to the 1000th place. Depending on which number they want you to round to that place. And when you round, you have to look at the next number. Based on the next number, you round the exact place they are mentioning. Any question? Was any explanation confusing to you? Any part of the explanation? No? So that's the fourth step. Completely unrelated to recess. There is no way we can convert them into something. So we put a letter, which is ln. As a result, power comes down, and then ultimately we solve for x. You try one. Same process. Oh, in the final exam. One of these or the fifth time, you have at least one of them in the final exam. For your next exam, you definitely need a calculator. There will be few questions in the calculator part. Ready? This is your first step.
Use ln, put on first degree.
So we apply ln on the left side. As a result, this power comes down. So 2x minus 2 ln of 3 gives us ln of 2. Julia, what is our next step? We divide by ln of 3. So we get 2x minus 2 is ln of 2 over ln of 3. Stephanie, what is our next step? We add 2. So 2x is ln of 2 over ln of 3 plus 2. Ryan, what is our last step? Wonderful. We divide everything by 2. And we get, don't assume that you can simply divide them. It cannot simply divide them because this denominator belongs to both of them. So if you want to divide, your choice is this. You write ln of 2 over 2 times ln of 3 because you're putting these 2 on this denominator and these 2 on this denominator. Plus 2 over 2. And then you can cancel them. That gives us 1. So we have ln of 2 over 2 times ln of 3 plus 1. Because this denominator belongs to both of them, so put these two on both denominator. And we cannot cancel these two with these two because this two is inside the machine. So it's not free. This two is free, but this two is not. It's inside the machine, so it cannot break it down from the machine. So if it's in the non-calculator portion, that's how I say. Most likely in the final exam, it will be in the calculator portion. So what's the answer in decimal? Who has an answer? This is 3. ln of 2 divided by 2 times ln of 3. We are adding 1.
1.381.
1.381. Stephanie, do you have the same thing, different thing? 1.315. So 1.3 is correct. And then 15 and 81 is a huge difference. Anyone else has something different?
Do I have to put, after I put the 2, do I have to put ln of 3 inside of the parentheses or no?
So for the calculator, if it's in a scientific calculator, then parentheses does matter. So first start with the parentheses because the first thing is a fraction.
No, but I have the fraction. Like I have.
Oh, you already have the fraction format.
Yeah, I have that.
Then you don't have to do that.
Oh.
So in my case, I don't have a fraction format. So I have to start with the parentheses. And then 2 ln. We are dividing that. Now we have 2 things on the denominator. So if you already have a fraction, you simply write 2 times that, it will be the fraction. But if you have a scientific calculator like mine, then you cannot put 2 times ln of 3. If you want to put 2 times, you need another fraction, another parentheses to work with. So our denominator has 2 terms, so I have to put another parentheses. 2 times 3 ln. I'm closing both parentheses. Look at what I have right now. ln of 2 on the top divided by 2 times ln of 3 on the bottom. So ln of 2 on the top, 2 times ln of 3 on the bottom. With that result, I'm going to add 1. So plus 1, 1.315. They're close, but when you look at 15 and 81, it's a huge difference. So you have to play with your calculator before exam, before the third exam and before the final exam. Just having a calculator is not enough, trust me. If you don't know how to work with the calculator, it's useless during exam because you're going to get wrong answer. Any question? Now the last type. The difference between this one and the previous one is the 2 things. One is here, our base is specifically E. And second difference is we don't have only 2 things, we have 3 bases. Now when we have 3 things, it doesn't matter what is our base. When you have 3 things, first you must combine 2 of them. Because we want to have 1 fraction, 1 exponential, 1 base and 1 side on both sides of the equal sign. We don't want to have 2 things in one side of the equal sign. We want 1 thing on the left and 1 thing on the right side of the equal sign. So this is our first step. If you want to combine 2 things into 1 thing, which one we get rid of? 3. 3 is a constant, 60 is a constant. So to make our life easier, we add 3 to both sides. So we get e to the 2x is 19. And now we are happy because we have only 2 things on each side of the equal sign. Sorry, we have 1 thing on each side of the equal sign. So what do you do? Next step?
Then and now
It's actually not called multiplying, it's called applying. Because it's a machine. We are not multiplying this by a machine. We are putting this inside a machine. So we are applying ln natural log. Now, previously we've seen that when we applied the log, we had ln of the number. Now here, ln and e, they're enemy of one another. As soon as they get next to one another, they fight so hard that they both die. They become one. So it doesn't matter how do you write them. You can write e to the power ln, or you can write ln in the base e, or you can write e and ln, or you can write ln and e. It doesn't matter how do you write them, as long as they're next to one another, all of them become one because they fight with one another. That's why this e and ln here, they fight with one another, they die. We don't have anything left except for the power. So we have 2x equals ln of 19. Our life is much easier. What is our last step to get that 7? We divide by 2. So x is ln of 19 divided by 2 for non-calculator portion. But for calculator portion, you have to find the how much is it. I think in the 1 point what? 1.472. Oh, this is easy. In the book, they should have put logarithm first and then exponential. Because in the exponential, we are using all the properties of the log. They did opposite. Okay, you try one. And remember, we have to apply log only when our exponential term is alone. Let me write this down. We are allowed to apply log or ln only when the exponential term, which is base with the power, is alone. This is called exponential term, base with the power. We cannot have anything in the front. We cannot have anything on the side. It has to be alone before we apply our log machine. And sometimes they give this type of question in the final, sometimes they give the other type. Stephanie. ln of 3.2. How can you have 3.2?
Because you have 4 divided by 3.
Okay. So add 4?
No. Not add.
4 is already added here. Subtract, right? We subtract 4. So you get 3 e to the x is 1.6.
What?
We divide by 3.
And I got
e to the x.
0.
Keep this because it's a fraction. If you keep it, your answer will be accurate. And if you round it now, your answer will be rounded if you apply ln. So since this is a small thing, keep it.
Now it's 5
Now we apply ln to both sides. What happens to e and ln? What happens to the left side? ln and e? They canceled out because they don't like one another. So we didn't have to solve for x. It's solved automatically. Now how much is it? 0.63? Okay, let's see. We have 1.6 divided by 3. We are applying ln. 6 to, let's round to 3 places. 6286. 6286. That gives us negative 62.
You put 3 places inside the log. You put
Uh,
0, you put log, ln of 0.533.
If you want to round to 3 places at the end, then you have to put 4 or 5 places inside.
Okay.
So that's why don't do this math. Keep it and do it directly. ln of 60.
Okay.
It will give you the accurate result. Just 6 to 9. Right? 0.6286, so 8 becomes 9. Okay, any question? So for these parts, we definitely know how to work with the calculator, how to insert this in the calculator to get correct answer, not a wrong answer. And with this, you're done with all 5 types of exponential equations. There are 5 types. We know all of them. Same guys, so it doesn't matter which type they give you. All you have to do is follow the step for that particular type. Now comes real life application. When actually we use them. Surprisingly, we actually use them a lot in our life. A lot. Especially if you work in banking system. You're working in So banking system means you're investing money. Okay? So when you invest money, you go to bank and you tell them, well, I have some money, some saving. I want to invest that so that eventually my money grows. Now they will ask you, well, we understand you want to invest, but you have to tell us what type of interest would you like to get. We have 2 types of interest. One is compounding continuous, and another is compounding n times in a year. What does that mean? I have a little details. I'll go over it later. But depending on your answer, you get different formula to work with. Let's say you reply that I want to get continuous compound interest rate. It means this is the formula. A equals PE to the power RT. People call it part formula. Part, PE part. So they call it part formula. And if you say, well, I want to do compounding this many times in a year, then this is your formula. Now you may wonder, what is all these letters in our formula? Here they are. A represents your final amount. How much you're going to get back after investing your money for a certain amount of time. P means principal. Principal means you're saving. How much you are investing in initial amount. One is a number. R means the interest rate. What is the interest rate? For example, the tax rate we pay, our tax rate is 8.575, something like that, right? 575. So that's the R, interest rate. N means how many times you're compounding in 1 year. Let's say you want to do annual compounding. Annual means we do it once a year, right? So N should be 1. If someone says, I want to compound monthly, monthly means how many times you are going to do it in a year? 12 times. So N will be 12. On the power, we have M times T. This N and this N, they are the same, how many times you're doing it. And T means how long, it's time. For how many years you want to invest the money. So final amount, initial amount, interest rate, how many times you're doing it in a year, and how long, for how many years you're going to invest. Same thing here, A is the final amount, P is the principal, E is the saving E we are working here. So E is a special number, this is here, and this E has a power R interest rate, T is the time. So you must memorize this formula. Now, what's the difference between them? You don't have to know them, but I thought knowing about this will help you in your real life. So compounding, the first formula, it's saying compounding how many times in a year. So compounding means how many times you want to check your interest rate. For example, if you want to compound 12 times a year, monthly. So what does it do is, after the first year, you have your initial amount plus some interest rate. Let's say you invested $100 with interest rate 5%. So after the first month, let's say that $105. Now for the second month, your interest will be charged on $105, not on $100. So you got, let's say 105, 5% is, let's say 107 or something, I don't know. Let's say $107. So in the next month, the third month, interest will be charged on $107, 5%. And then on the fourth month, whatever you have, interest will be charged the next amount. So the more time you compound, it means after every cycle, whatever money you got in that 1 month, you are putting your interest, you're charging the interest on that amount. So as a result, the more time you compound, the more money you get. That's the compounding on a certain time of a year. Continuous compounding means you're compounding every second, every moment, okay? So after every second, whatever money you have, interest will be on that. And then after another second, whatever money you want, your interest will be based on that much money. So you're compounding, you are putting your interest on the new money. So the new increasing money, you're increasing your new getting back the final amount. So that's the difference between doing annually or monthly or continuous. The more time you do, the more money you get. Now we have some example. So since our equation has so many variables, so based on the variables, we have that many types of equation. For example, sometimes we are looking for A. They will give us all the other information. Our job is to find out what's the final amount. But in some scenario, they will give us other amount and they will ask us to find our principal amount. So these are second type of equation. Find how much you had initially. Or sometimes they will give us everything else besides R. Oops, it's too dark. Besides R. So our job will be find what is R. And then lastly, the last type, I mean, not the last type. Yeah, last type. Last type will be finding our time. We'll never have to find M because they will always tell us how many times you're compounding. If you're doing it continuously, there is no M. Besides that, if you're doing it some other time, then we have an M, and they will always give us the M. So we have 4 scenarios to work with. Now the first scenario, everything is given except for the final amount. So here is an example. Suppose you're investing $7,000 with interest rate 3.5%. How much money you will get after 5 years if you compound annually? So let's see what is given here. Since we are doing annually, that means we have an N. N means this formula. A equals principal 1 plus R over N to the power NT. Anytime it's not continuous, that's your formula. Now, what is our principal? $7,000. That's the initial money you invested. What is our interest rate? 3.5%. But in the formula, we are not allowed to use percent. We have to put decimal. So 3.5%, how are you going to convert into decimal?
0.035.
You move your decimal 2 places to the left. So we get 0.035. Always move your decimal 2 places to the left to convert the percent into decimal. Time. How long time we are investing? For how long? 5 years. And now finally, in this example, how many times you are compounding in a year? Once. So we identified all the variables we needed to apply here. So it's time to apply. 7,500 initial, interest rate at 0.035. We are doing it once, and we are doing it for 5 years, so in a 7. So 7,500, 1 plus 0.035 to the power 5. In other words, is 7,500, 1.035 to the 5. I did write 7,500, right? Oh man, my bad, sorry, 7,000. Why do you keep writing 75? It's 7,000. Okay, calculator time. How much is this? 1.025 to the power 5 times 7,000. What do you get back?
I got 8,313.
8,313, 80 cents. Let me give you something different. All of you have your phones, right? So try it. Trust me. Just having your calculator is not enough if you don't play with them. Play with your calculator and see if you have the same number or something different. Same thing? It's 80 cents, right? Not 81?
80 cents, yeah. Yep. Unless you want to.
No, it's money, right? For money, we always have two places. We get cents. Try the next one. That's 3. Same formula, just our M are different. Quarterly. Quarter means what? How many times you're doing it in a year?
4.
4. Because we have 4 quarter in $1. So 4 times. Monthly. If you do it monthly, how many times you're doing it in a year? And if you do daily, it's 365. So you rewrite this equation. The and this end are different. The exact same formula, just ends are different. And if you want, you can put everything in the calculator. If you know how to put everything in the calculator. Let me write down the first one for you. We have final amount is 7,000. 1 plus 0.035. We are doing it for 4 times. And we have 4 times 5, which is 20. So you plug everything in the calculator, and that will tell you the final amount. Say it again, I forgot. 8,330. What you going to do? If you want to get something, no. That's what it is. the formula. Please write down the formula. Let's write down the formula. For compound, not. This is the formula. And for it's hard. The continuous final is because continuous we cannot get number of n. Continuous because this is what is it? Yeah. We don't have to turn exponent for two. Oh, parts here. Great. We don't answer. Oh, basically, like my family is about I remember. When one day I don't hurt myself. But if we have like my computer, calculates, you can simply put everything in the calculator and they'll just.
For the sake of like not, for the purposes of trying wrote down. But of course, I just look everything at
Well, I said
the purposes.
right, and then the answer.
Okay.
Three.
Okay. So all you want to see is just, whatever. Okay.
So I definitely want to see your substitution. For M12, our amount
This
is
it's gonna be part of the calculator portion, right?
mhm,
Okay,
0.035 over 12, and 12 times 5 is 60. So I want to see this.
And you still want us to like write down the
Final answer. So you must write down the equation, the substitution, and then the answer. If you just give me answer, your answer will be your point will be 0.
so
Because I don't know how did you get it, but you have to show.
The scientific calculator, the most advanced calculator. in the-
No, if you want, you actually need a graphing calculator. But if you have a scientific, you're fine, no problem.
Oh, no, but do you need a 1084 for the final?
So for the next one, our final amount. For the final amount, we have 7,001 plus 0.035 over 365 and 365 times 5. So show me your formula and then the answer. You don't have to do this many of them. You can simplify the calculator, and the calculator will tell you how much it is.
So if we really like that, 80 we're gonna add it to an extra, that's good.
So math right this and then that.
Okay.
I don't want to see these inside how much is in the how much is that. I don't want to see all those steps. I want to see this one. Okay. If you do the steps, it's up to you. Okay? I'm not going to punish you, but what I require is these two things: substitution and answer. Now for continuous. For continuous, we cannot put a number for n because continuously continuous forever and ever. So that's why we use a different formula. People call it part, P-E-R-T, part. So our principal is same 7,000. Now E is the letter, the number E in the calculator. Our interest rate is 0.035 and our time is for 5 years. We have 8338.72.
Yeah.
72. Now observe something cool. When you do it once a year, we have $13. 13.80. When you compound 4 times, it becomes 32. From $13, you get increase 32. If you do it 12 times a year, from $32, you get $36 now. If you do it daily, every day, now we have 856, the 36 becomes 38. Do you see they're increasing? The more time you compound, the more money you get. And finally, the largest amount we get is doing continuously. We cannot get anything more than that. Because continuous is our last resort. We have nothing more than that. So that was type 1, while we are calculating our final amount. Now, second type, all the other informations are given. We need to know how much we invested at the beginning, or how much we need to invest in order to get the final desired amount. So you need $14,000 in 8 years. How much money you need to invest today with an interest rate 7% if you decide to compound quarterly? So you're thinking about your future. For some reason, after 8 years, you need $14,000. And the bank told you, well, our interest rate is 7%. And you said, well, I decided to compound quarterly. Then how much you have to spend today? See real life scenario. Can we bargain with the bank about interest rate? Or they give us a fixed interest rate? You guys know? Can you bargain much? It depends.
I've worked. So like it depends, like it's like if you have certain non they want to keep their high capital requirements.
So what is the highest amount we can bargain? Like how much interest rate?
So like hard rate, but usually like the So, well, if they get.
So the more money I invest, the higher interest rate they're gonna pay me. And do you know how much is the highest interest rate they can pay?
Like, 6 months. But it's locked in. It's a CD. So, yeah, 4.2. I think it's average 5%. Like, a whole bunch of but like the.
Does it matter the compounding, like do you want to compound continuously or quarterly? Does it matter on compounding?
It's like a safe. It's not.
So 7% is unrealistic, probably, right? Compared to the real life scenario. Would it be? We pay 7%. We pay high interest rate, but when you want them to pay us, they don't want to pay us. So find out how much you need to invest. In the final exam, they'll ask you 2 of these. Usually 2 of these come in the final exam, depending on 2 scenarios. Either you need to find the final amount, or initial amount, or interest rate, or time.
We know what the extensions again?
So you are compounding with a number, right? If you compound with a number, your equation is the first one. Because here we have a number for compounding. And if you do continuously, then it's the part.
Those are the only two extensions that we should know.
Mm-hmm. So in here, we are compounding with a number. Quarterly means how many times? 4. So n is 4, so you have to use the formula that has n in it. Done? How much you have to spend today?
I think it's 8,335.75 cents.
8,035.
$8,035.75.
75 cents. Basically $8,036. Anybody has anything different?
1 more. 0. 20 cents.
Definitely it's wrong. You know why? Because if you started 21,
Yeah, it's strong.
very long. Okay?
No.
If you started
Pretty sure I
21,000, why don't you have 14,000? We have to gain money, not lose money. So what mistake you made? What formula you used? Tell me your formula. A equals? Mm-hmm.
1
R over N, right?
Yeah, over and.
Okay, so what's the final amount? 14,000. Initial, we have no idea. What's the interest rate?
7, but 0.07.
0.07. How many times?
4.
4. For how long?
8.
8. Since you're solving for P, so we need to divide both sides by that thingy. 1 plus 0.07 over 4 to the power 32. 1 plus 0.07 over 4 to the power 32. So they cancel out and we get P equals this thing. 14,000 divided by 1 plus 0.07 over 4 to the power 32. So let's see in my calculator how I'm going to do it. 14,000 divided by a big parenthesis I actually had to put a double parenthesis. One is for this and one is for the power. So 1 plus 0.07 divided by 4. That's the first parenthesis. It has the power 32. That's my second parenthesis. Enter. 8035.75. Yep. So you see, how did I insert my 14,000 and then double parenthesis? One parenthesis for this and another parenthesis for the whole denominator. So double parenthesis inside. For the power, we use this thing. X to the power 1. So if you're using a scientific calculator, you need to see this symbol. Something with the power something. And then clicking that, we get 92, then close the parenthesis. So when you insert your number, the parenthesis does matter. So this is our final amount. So today we need to invest $8,036 so that after 8 years, it becomes $14,000. So how much we are going to gain yearly? 8,000 after 8 years become 14,000. So in 1 year, how much we gain? Double is too much. It's 1,000 something, right? Even less than 1,000. Wow. Okay, the next type. Interest rate is missing. Find out how much you want to bargain with the bank to give you the interest rate. So we have an initial amount 2250. We want that money to become 3,100 in 6 years. Really? Why that long? We will have 31,000 instead of 3,100, right? Okay, they want 2,200 to become 3,100 in 6 years, and they want to compound continuously. Then what should the interest rate bank give us? And we want the interest rate as 100. 100 means how many places after the decimal? Sure. So this is a decimal. That's the 100 place. Round to 2 places after the decimal. How are you feeling about these real life scenarios? Are they interesting or boring? Interesting, right? Not interesting, Stephanie? Why not? Why not? Think about your life. You want to put yourself into that scenario. What, Angel?
It's like I'm in finance class.
You want this in finance? Actually, I never took any finance class.
Huh?
I never took any finance class. Actually, I did financial math. Financial math is finance, right?
Like similar.
Yeah. In undergrad, we learned put, call, put option, call option, and then something.
If you learn how to calculate something, so percentages. No, like
They taught many things in that class. It was way so many years ago. Around what? Before definitely 2015. Yeah. Phone should be used only for calculation, not for texting. See how smart I am? I could tell you are not doing that. You're doing testing. So find this. You're finding test rates. And since our test rate is on the power, so we actually have to apply log to bring the power down. Definitely. And if you're done, I have more. I need time. You have more zeros. So divide by 2, and then 6 comes down. Oh, wait, this is E and ln. Yeah. E and ln. That's along. Yeah. What is that? Pardon? No, like.
So is that what's oh in the eight times.
Probably don't
So
move
eight
them.
so that's eight speed. So this one. Yeah. So eight is
I was just wondering.
And then here, right? Here's
and the years you go.
Probably
The rate with one part.
we are working with nonlinear equation. And when two functions that intersect one another, you're looking at the solution. You have to remember this. I remember seeing that. We have this, and then figure out what are these two numbers. I remember kind of like that. So here it's thinking because they give it a library to find out what is that value. But the one here they really do the x value to find the y value. I don't know. And this even in the homework. In my lecture, I don't remember. Yes, 5.3. This is now to 100.
Oh, and so that's
So we found it. Okay, so it's 26. 12.5. 7. So 107. 7. 25.
So in this.
So there was another calculation.
You natural one or right?
Select. This is going to be the key row to be select.
After 11,
But if you select the point unless you do alone. And this whole thing doesn't have the power.
Okay.
Only E does. Why I don't get what's wrong. So the question was.
So- that's 6. Yes. 6R. Yeah. This is same. You get 6. I like it. But because I like it. Oh, we have to get by 31 in their both times, so that was 31 right?
So,
oh no. Me too.
go to 2.0. After
Get E alone.
you by 6,000 years, 1,000 years, 100. Since you go up, another 2
The whole thing, yeah.
So you tell me to go up to the 4 places. And then you're gonna move 2 places.
Yes.
So you get 6R. Yeah. Right, that's it. Right on.
So this
Um,
That's what I want.
the last well,
Then, we have to plug this, right?
Yeah, yeah, it's perfect. So every time you see continuously, you always do that.
The formula and log.
Yeah.
That's what I think I can say about it. So you get 1.1, everything from our.
So annoying.
We cannot get to a point where so the goal is to get rid of damage. Yeah.
Yeah.
Yeah, it's 5.34%.
We got like this problem.
Station is kept set.
No, I love having this.
Yeah.
And you gotta find the yard, so. Actually, it's the. Just divide 6 by the outside. Yeah, and then you try to find the yard, you don't know. That's 32.
It cannot bring it down. It cannot bring it down. And now,
Yeah.
Right?
so once you give the down,
So.
now
Yes,
people
so you see the final. The 6 is.
Okay, so. Also, I was like.
Yeah.
So.
So I got E times 6, and you divide both sides by 6. You have everything.
You only
Yeah,
have about, but
Yeah, but you have to divide by 6.
it is an equation.
But it looks like the same.
That's what
So, did you write down the notes? I will, yeah,
Thank you.
log ln is only ln is used. To use one exponent sum is alone. You use exponential sum is alone. No, it has the problem. The first digit gets the problem.
It's easy everything.
Jannah. You didn't do it.
Because
Second one, you're solving for finding time. If you're finding time, they have to be one. You're finding for time. And it's all for T. T is on the power. So that's the numbers.
I heard about it.
Because I will be.
If you're trying to get to like the beginning of robot does robot does
Do I have more? Okay, so since we are compounding continuously, so we start with parts. A equals P e to the RT. They gave us an initial amount, 20 to 50, and 6 years, so our time is 6. The final amount is 3,100, and they want us to find out interest rate. What is this interest rate? So anytime you're solving for either interest rate or time, you must apply ln. But we cannot, because we have this problem, 2250. So first we get rid of 2250 because we are allowed to apply ln only when our exponential term is alone. So we get this 0 cancel out, 310 over 225 e to the 6r. Now we can apply ln to both sides. So they cancel out. And we have ln of 310 over 225, 6r. We are looking for r, so we don't need the 6. We divide by 6, and now we get the interest rate. It says round to nearest 100. It means in the percentage, we have to have 2 places after the decimal. So go to our calculator. And we have, my calculator is special. First, I have to apply the numbers. For the numbers, I need to start with my parentheses. 310 divided by 225. That number, we are applying ln. And whatever we get, we divide that by 6. So we get 0.0534. 0.0534. We have to go 4 places here because after percentage, we want 2 decimal places. So since it's interest rate, it should be a percentage for our final answer. So interest rate is 5.34%. The next one, the same problem, we are finding time, but our time is on the power. So we must apply ln to bring our power down. And it says do it continuously. For continuous, our life is easy. A equals part P e to the RT. This time our final initial is 3,600. We want to get 5,500. Our interest rate is 7%, means 0.07, and we don't know how long time it takes. We are facing the same problem. Our exponential term is not alone. So we need to divide both sides by 3,600. The 2 zeros cancel out. We get 55 over 36 is e to the 0.070. Now our exponential time is alone. Our base and exponent So we go ahead and apply ln to both sides. E and ln fight, they both die. So we get, let me do it on the side, it's too small. We have ln of 55 over 36 equals 0.07 t. Since we want to get the t alone, so we divide by 0.07. They cancel out. We get t equals, calculator, 6.054. Since it's year, so I think whole number is fine. 6 years. I have one more. And it's not continuous. But we are still finding the time. This time we are not compounding continuously, but we are compounding annually. Here's our last example from real life. So my question, are we going to use the same formula as the last one? No, we cannot. That formula is only for continuous case. Now we are not doing a continuous case. We are doing a compounding a certain time case. So what's the formula we start with? A equals what? A equals P and then? 1. R over N. Annually means how many times you're doing it. So what is our N? 1. So, oh, this is an interesting one. How long it will take to double your money if you invest $5,000 today? So if you invest $5,000, what is it? Great. They didn't tell us the final amount directly. They are tricking us here. It says double $5,000. So final is 10,000. Initial is 5,000. So how long it will double our $5,000? If we invest with the interest rate 3.5, 3.5% becomes what in decimal? 0.035. We are compounding only once a year. So 1 times t.
Is it the same problem we want to use?
But again, we cannot use it unless we have base and power alone. We can divide 5,000. So you get 1.035 to the power t. Now it looks much cleaner. I added this is same as 0.035. I added 1, so you got 1.035 inside. And 1 times t is just t. So this time, you don't have e, so that's not going to cancel out. It's same as the equation we did before. We have completely 2 different bases. So how do you solve for the power. We apply ln H's power or log H's power. So power comes down. Oops. And we get that. What is our last step? By? Our goal is to get the t alone, right? So dividing by ln2 doesn't help us. We need to divide by this. 1.035. ln of 2 over ln of 1.035. How long? How long? 20 years? 20.15. 20.1 means 20. Month. So 20 years and then some months. 15 over.
Also 1 more year.
Yeah, but round down. It's round up. Technically, yeah, we need 21 years. But 20 is fine. Really? If you compound only once a year, it takes 20 years to double your $5,000. When you're looking for time or interest rate, we have checked LN because they are on the power. Okay, we're done with exponential. We learned all about exponential we need to learn in this class. Any question on anything about exponential? Our next topic is logarithmic. Oh no, man, I forgot another type. Sorry. There are 2 more types of exponential application. One is growth and one is decay. So bacteria grow really fast. So if you want to study the life of bacteria, we work on exponential function. And then, did you ever hear about half-life?
Yes.
So half-life means you're decreasing really fast. It's exponential. So double life means you're growing really fast. Half-life means you're going down really fast. And they have the same formula, but they use only the part formula, okay? We don't need the compounding formula anymore. For bacterial life, for this thing, there is only one formula part. Now, that's one example before you go. It's a sphere population P. Anytime you're working with any type of population, human population, bacterial population, or some other type of population. Population type means you can use this formula, part. So population P 2 years after the year 2000 can be approximated using the model P equals 20,000 e to the 0.05 t. So they gave us a human population or some type of population model, and they want us to figure out what would be the population size in 2015. So for 2000, for the year after 2000, that's the formula. So year after 2000, observe here, year after 2000. So exactly in the year of 2000, what was our T? No, when we had the year 2000, 0. Because it says after 2000, right? So exactly in 2000, our year is 0. So in 2001, what year we had? 1. In 2002, what year we have? 2. Now we are in 2015. So what year we are in? 15. In other words, they're telling us, hey, substitute 15 for your t. Okay? So they gave us the formula.
They gave
And this is P, this P not principal, it is population. So our population is 2000 e to the 0.05. In the year 15, our time is 15. So we go to the calculator, whatever we have, that's the answer.
Why there is p power 0.05?
Because they found out that the population is growing 5% per year. And you want to see how many, after 15 years, how many population, what is the population side, how many people they're living?
4,234.
4,234. Any decimal?
It has a lot of zeros and then 3 at the end.
It's fine. So that's the population. One more. How many years it will take to get 27,000 population? So this 27,000 population of P. So 27,000 is 2,000 e to the 0.05 t. Now they want us to find this t. So what do you do? What is our step 1?
Divided by 2,000.
We don't need this 2,000, so we divide by 2,000, so they cancel out. We get 27/2 e to the 0.05 t. And now what do we do? Since our power, t is on the power, so we need to bring it down. We apply ln, they fight, cancel out, they die. So we get ln of 27/2 equals 0.05 t. Finally, we can solve for t. We divide by 0.05. And how long it takes? $52 years? Wow. Okay, think I exam. This is actually a final exam question. So in the final exam, they give one money problem, one bike problem. And you'll see more final exam question in our next class. So have a good weekend, everyone. Don't forget to do your homework and online quizzes.
All of the by the end of the semester.
No, I said the due date.
Oh,
I don't remember the due date.
But now it's not even
The penalty? Wonderful.
just give you score after the day. 4 hours.
I do.
Oh, wow.
It's my bad.
You need to play the calculator. Or it's only for the.
You see?
Yeah.
So what problem
we're doing.
we have 27,000 and 2,000, so they can do it. Yeah, that's 27 divided by 2, not 5.
Okay. Oh, yeah. Okay. And then for this one. Okay.